ladies and gentlemen. It is Thursday, October 6th, 2022. I'm here with Mark Colababa, CEO of Adamera Minerals, a stock I've followed and known for a long time. Mark and I are friends. Mark put out what I consider a pretty important news release this morning for a couple of reasons. One is that he reported a pretty nice intercept, over 10 grams, over almost 4.5 meters. But for me, the more important thing, and this came up more even when I talked to Mark later, was one thing that this current drilling that they did seems to have established is they think they've got a pretty good handle on the dip and the plunge of this thing, which means hopefully they can chase the high grade stuff now to depth. But the other important thing that came out of this was, and you can see it in this table, Mark will go into this in a minute, but there's a table in front of you right now of the different individual samples in the two drill holes. And there's a very strong and clear correlation between sulfide percentage and gold grade here. And the sulfides are basically pyrite. That's important because, I would say honestly, for the first time at Cook Mountain, there seems to be a very clear targeting and vectoring method that appears to work, and that's got some pretty important implications. Understand that this drill area is only a few hundred meters from a recently producing mine called Lameput. Lameput was 1 million ounces, but the grade was high. It was 8 to 10 grams per ton, and it was a very profitable operation. But there's almost no information about it. And one thing that Mark will show you today is a long section which they only came across recently, and he's going to explain how that relates to the area immediately around this drill discovery, because there's some pretty important parallels between the old mine and the area where he's working right now. I think this area actually has a lot of potential. I would say this is, in terms of potential to generate good results and potential to grow this thing. This is probably the best looking. This is probably the best looking target in terms of what looks like ease and efficiency going forward. That's always been hard. So let's welcome Mark Colababa, CEO of Adamera, ADZ on the venture, DDNNF, OTC in the U.S. I don't think I'm talking out of school, Mark, by saying that Cook Mountain hasn't been the least frustrating place to work. The models changed, and it was hard to chase stuff. But this, at least at Cook Mountain, Buckhorn's a different story. But Lameput seems like the first place where you're really getting a handle on it. You're getting vectoring, and this is something it's not really news. You and I have talked about this project probably for the last couple of years, and I know as you and Martin kept layering data on, stuff just kept making more and more sense. And I think the drilling you put out today kind of verifies the modeling that you and Martin have been doing. You hit exactly what you thought you should hit.
Yeah, thanks, Eric. In fact, better than what we expected to hit. It was, what you're seeing here in this table is LS22-1 and LS22-2. These are two follow-up drill holes for what we called it PL6 last year. And that drill hole hit in very shallow depths, 2.7 meters of 4.7 grams per ton gold. And that was a pretty decent intercept. Only just about 3 meters, but still decent grade. This year, we went in with the first hole. We saw sulfides. We weren't that excited by the sulfide content, but it did produce an intersection that was 1.5. You can see it right here, 1.52 meters of 1.6 grams per ton. And all I can say is, luckily, we did that second hole to the north of that, because that second hole came up with 10.5 grams per ton over 4.42 meters. And these depths they're all shallow, but from here to here, that's not that far. It's only about 20 some meters maybe. And you're seeing a very big change in the depth of where we intersected that. So quite a change from LS22-1 to LS22-2.
Okay, so I mean, the implication there is that this. I mean, you kind of know now because last year's intercept and these two, you got a much better handle on how this thing's dipping and plunging now.
We have a handle. Last year we had no idea because it was one single hole into this target. Uh,
Right.
what I would say in that news release we just wrote, we have a tentative southwestern limit for that mineralization. Well, I don't actually believe that that's entirely true. I think if you step back a little bit more, we're going to see more mineralization associated with the southern extent of that, because we do see an awful lot of gold in the soils, and it picks up, and it's still part of that meso-Lamasse, which I can show you. But this hole wasn't disappointing. It just didn't hit as much. But this hole hit a lot more. What this 22-2 had that 22-1 didn't have was a massive sulfide content. And you really hit it when you said we're seeing consistently with regards to gold content and sulfides. And we've drilled a lot, we've had a lot of intersections, but we could never really see any clear cut correlations. And just to lay it out for you, here where we get 4.54 grams per ton gold, you get about 20% sulfides. Where it's 14 grams per ton gold, we're seeing 30% sulfides. And where we get 21.24 grams per ton gold, we're into a zone that's about 80% sulfides. So that's a pretty clear cut. And then there is a small zone in between 31.9 and 31.7, a small zone that has about 10% sulfides that only has, well, it essentially has no grade, very low grade gold. So sulfides are clearly important. And if you're going to be looking for gold on this project, you look for the sulfides. And just to make it even better, you're looking for the high concentration of sulfide. And there are means of doing that either through EM or through SP and even geochemistry. We have a real way forward, at least to identify targets on surface. Now, we've got so far 3 drill holes into that body, or into that target, into that mineralization, and we've seen quite a lot of variability in a fairly short distance. All 3 of these holes are essentially from one pad, and we go from 1.6 grams per ton to 4.7 grams per ton to 10.5 grams per ton. And each of those holes is stepping to the northwest a little bit further and stepping down dip or down plunge on that mineralized horizon. So is that giving us information? You bet. We've been able to put this into Leapfrog. We can draw lines that would tell us what we think it's doing. It's probably plunging at about 50 degrees. Is there, will we see changes in that? Probably. But at least we have something to shoot for. And currently the drill isn't on site. It's up on the Buckhorn project. We've got a second drill starting today on Buckhorn. We want to wrap that up pretty quickly and then bring that drill back here. And we've got drill hole pads laid out, and we're going to start more permitting because we do have a lot of other targets that are very similar to this one. And we need to prepare for that. And we can drill probably up until the end of December, breaking for Christmas. I do have.
Okay, and can we take a look at the lane put section next before we go into your other targets? I mean, because I think that gives us a good indication of what. Oh, that's your core from the high grade.
Yeah, I forgot this was in here. But here you can see the sulfides. Here you're getting 4.5 grams per ton. You can see how the sulfide content diminishes, and you're getting down to 0.041 grams per ton gold. Then again, here you're seeing a pickup in sulfides locally. And here is this is just full of sulfides, up to 80%, and you see you're getting your 21 grams per ton. Very easily recognizable. Right. And here you're getting, actually this, 0.02 grams per ton is probably coming from that little section here, and the rest of this is probably not carrying a lot of. And I think there's more to this than just simply the sulfides. The sulfides are the easy part for us, but you do need to see silica, and these zones with high gold have very intense silicification and a lot of brecciation. And when you do look at the sulfides here, the sulfides are replacing the limestone. And here, the sulfides are really occurring along veins. You can see that here. You haven't seen that replacement texture building up. So not only do you need to see the high sulfides, but you want to see the replacement textures, and you absolutely need to see the silica. In fact, some of the limestone is completely replaced by silica. You can see limestone textures, but it's silicified. It's really an interesting rock type.
Okay, and bottom line going forward, when you're drilling, I mean, unlike in the past in Cook Mountain where it was cross, you know, I mean, you're still gonna cross your fingers, but cross your fingers and wait for assays. And at Lanefoot South, it looks like you've got something where you're gonna know. I mean, you won't actually know assays until you send it to the lab. At least you can say, yes, this is in the right place. No, this is in the wrong place. Let's adjust accordingly on the fly as you drill these holes.
Yeah, we what we can see visually here is really quite good. If we know exactly where our eastern limit is, we get into a rock type. If we hit that, we stop.
Right.
It's called the Knob Hill formation. We stop. If we see these kinds of sulfides, we absolutely know we've got to keep going. And I mean, that's no different than any project. The sulfides are really, really important. We know when we're in the zone because we have it. This mineralization occurs along a clastic sediment limestone contact. So that's important. And it's so important. It's exactly where the Lamefoot deposit is. The Lamefoot deposit is about 500 meters to the northwest. It's along that same clastic limestone contact. We have two of them because that strata has been folded, eroded off the top, and we have two clastic limestone clastic contacts. And this is on the eastern limb, and we've got new targets developing on both sides. And I'll show you that as we go on here. But visually, we have a lot. We can identify limestone very quickly. The clastics are obviously very understandable. And then the mineralization itself, there's no confusing that.
Okay, and let's take a look at this long section. And this is something I know you got relatively recently, like you haven't had this for years and years. Lanefoot was, I believe, was it Echo? I think it was Echo Bay that mined it.
Echo Bay. Yeah. This deposit, they really
And I
like
think it
this
was
deposit.
pretty much well, yeah, and I think it was mined before Kinross took them over. So there's just not much out there. I mean, I've looked myself. There's next to nothing in the public domain, but this long section popped up recently, and I think it's important to note how this, deposit looks, because what you really got here is 7 separate zones. They all seem to be, sort of cylindrical, I guess, ish, steeply dipping, steeply plunging, separate. They look like they're essentially separate zones. It's a little confusing because you're seeing, all those things you're seeing going back and forth. Those are actually the workings. They mined it by coming in from a couple of ramps, but the zones themselves are individually small. They have small footprints, but the grade was high. So even though there's probably, I don't know, at most 3 or 4 million tons here. I mean, they mined 1 million ounces out of this thing, and they made a lot of money doing it.
This deposit was really important to Echo Bay at the time because it really saved them. They had that mill was overcapitalized. They thought they had more ounces in another deposit, and it didn't. And when this came along, this really did save them, and it made them a lot of money. And just to look at this really quickly, you can see, I don't know if you can see it there, but there's a bit of a vertical scale that we estimated based on that elevation here and this elevation down here. And this would be the surface of the earth right here, and it really travels about like that. Maybe drops a little bit this way. But when you're down here, these are all completely blind deposits. And something like that, if you just clip the top of that, you have no idea what you're getting into. So you can see the difficulty in drilling such a thing, that you're setting up and you're trying to, if you don't drill deep enough, or if you don't drill the right angle, you miss these different bodies. But clearly, an interesting feature, steeply plunging, pod or lens or whatever you want to call it, or even a chute for that matter. But clearly something that is dropping to the north, and this would be the north and this is the south, and it was shallow here, but it continuously dropped down to the north.
Okay. Now, and now in your case, I mean, you've done a bunch of different surveys, and now that you kind of have a handle on the physical characteristics of these zones, I mean, the silicification and the high sulfide content, you've got something, you've got stuff that looks pretty similar to what you would expect the tops of these things, or what you would expect to look like above the tops of these things on your project, which again is only 600, 700, 800 meters away from these old ore bodies. Can we take a look at well, how about I thought the missile mass was really interesting. But here's a and missile mass is, something where you kind of need to have, it's something that you use once you've hit sulfides, because you have to actually stick a electrode down and energize the sulfides in place, and it kind of allows you to determine as long as there's connected sulfides, you can kind of determine the 3D geometry of it. And I know Martin did this earlier this year, I think.
Yeah.
And can you kind of walk through, like, what are we looking at here?
So here's the first hole that we did this year. Here's the hole from last
Yeah.
year, and this is basically the hole from this year, all in the same pad. This hole had the thickest interval, and it had the most intense sulfides, and it was the deepest hit. So the moment we hit that, we dropped a probe down the hole. We put it right on the high sulfide content. We then took another probe several kilometers away and put it in the ground in a swamp. We then had a transmitter, and we started transmitting current into the ground, which energized any of the sulfides here. So this black line, what you're seeing is the most intense conductivity for this zone. And we don't think this is something that's going to have a lot of strike length. What we do think it's going to have is a lot of down dip extent. So here's your body, something in here. Maybe there's another one picking up here, but we've hit the sulfides in here. But we think it's plunging off in that direction, something that's moving down into towards the northwest. But it's a very simple tool, and it essentially helps map the sulfide content in the ground from the surface. It doesn't give us a lot of 3D look, a lot of depth. You can't model this kind of data, but it's very simply telling us that the sulfides are trending in this direction. Okay. And that's a pretty good start for us. And we had that after the fact. Now we'll come in, we will start moving along this trend, and we'll see if we can hit this. We've hit this at 30 meters. Now we want to come back in here, hit it at 60 meters, and we hit it, try to hit it laterally. Okay. And we describe this as a rod or a cigar that is plunging down. It's not some big planar feature. It is a chute or a rod plunging down. So, think about that for a second. If you had a cigar plunging down, there's a lot of ways to miss that and only a few ways to hit that drilling. So you got to really be precise. You got to understand what you're doing. And once we understand that, we start stepping out more and we try to hit it. We're probably soon to be stepping out a bit more drastically than we have done. The other tool that's been really useful for us, because we are looking for sulfides, we're looking for massive sulfides if we can find it, is SP. And here's a really good example of that. Well, first of all, we don't know what this is. We don't know what that is. We don't see a lot of geochemistry on that. But this one in here, you see soil geochemistry up to 400 ppb, some pretty decent numbers. You got a really sharp value. If you look at that on this side, it's blown up, but here's the drill hole. First hole went right across that. And here you've got you start to recognize sulfides. And what we would say is, this is our contact. This is our limestone clastic contact. The deposit itself just sits about here, just off our ground. And it runs along another contact here based on that fold structure I was talking about earlier. So how many ounces can you get out of a cigar-shaped body or a rod that's plunging? I don't know the answer to that, but let's say you could get a couple of hundred or 100,000 ounces. You've got a number of these along that trend that have, and I mean, look at this, half a gram sitting in here with a beautiful anomaly. This has not yet been drilled. And you're right on the classic limestone contact. So this is what we need to figure out here. And once we can figure out what we've got, we then start to pick away at other targets along these two trends.
Okay.
And when we get the courage, we look at these features here, because not only do these things have very strong IP coincident with them, they've got magnetics coincident. We just don't see a lot of chemistry, but whatever is there, it's blind. We can walk out here and we can look at the surface. There's nothing magnetic, there's nothing conductive. There's also no geochemistry there, but something at depth is causing all of these features to happen. Here's a great example. There is nothing exposed at surface. The most you see is an alteration zone. You see sulfides in the clastic rocks. They're rusty, but you're not seeing much more than that. And when you do detailed soils, you start to see these numbers like 400 ppb. But again, we want areas with intense sulfides, and there's a beautiful trend right here that could very well be that. And here's your other one here.
And you've got, I think, a Permian advantage now in that one of the things you did earlier this year was you purchased your own rig and you get your own crew working that rig, because this is the sort of thing where really to test a bunch of these things properly, you're probably talking about a fairly large number of drill holes. I mean, very short drill holes.
I was going to say, you're taking a lot of drill holes, but boy,
you could get 20 or 30 hole program easy. I mean, because they're so short. I mean,
the program we're looking at now, apart from getting this figured out, and by the way, we think it's trending off this way. Isn't it interesting how you get this, the most intense geochemistry in the soil here, but as you start trending off to you see the soil numbers diminish, but you still have a trace of higher soil numbers where you're getting in the 20 to 50 ppb. And we see that. Quite interesting, actually. But to test that, we're going to need to keep drilling this and moving back under this way, because it's probably heading off that way. If we test that, how many holes do you need to test that? Probably a fair number, but they're shallow, and that's what's really nice about this target.
You're talking like 50-meter holes or something like that, or 75-meter holes, because as soon as you hit the classics, you're done. So you just move on to the next one, basically.
This is a really interesting feature right here. It doesn't show up so well in the SP, but it shows up really well in the IP and the mag. But there are some east-west features that we see, and maybe what we're seeing is these. If there is a mineralized zone here and here, perhaps they're dropped down by these east-westerly faults, and it's something that's maybe happening here, where eastern structures and these deposits are stepping down from the south to the north, and they're cut by something like east-west structures, and we certainly have that possibility in here as well. And this is only one data set. I mean, we have a lot of data sets. The SP really did a lot for us, and this is very detailed SP. It's every 10 meters. So imagine we're taking a reading every 10 meters, and it really did pay off. And this has not yet been tested, but you've got gold values up to 173 ppb sitting in a beautifully developed SP anomaly. It's the only two things I can give you that would be sulfides or graphite. Well, the fact that you're seeing gold in these things would rule out graphite, and we know we're in a system where we see sulfides, and we haven't seen a lot of graphite out here.
Right.
Which doesn't mean you can't. These ones worry me a little bit more because you're not seeing the gold here. But if it's blind and it's buried, you may not be getting enough gold coming up. But,
right.
Bit more risky.
Yeah, I mean, I think this is, the market's already traded flat. I think it's a bit tricky to get your head around the concept if you don't really follow the company. But this is a set of very good looking targets. I mean, you just drilled 4.5 meters at 10 grams, in one of them, but there's like 10 targets here and two or three others if you want to start getting brave and just hitting the SP anomalies without geochemistry. It's very reminiscent of the actual Lanefoot mine, which sort of be on the top of this map here. It's only half a kilometer away from where he's drilling. Uh, and again, this is as we know now, this is what Lanefoot looks like. It's a bunch of steeply dipping bodies with more dip length and strike length. That's really what their ore body was. Their ore body was a series of chutes. So this is very, very reminiscent of it. I mean, I really like the odds here now that you've pulled all these different pieces together. And before we wrap up, we should maybe at least mention the fact, because as you said at the start, there's two there's two drill rigs at Buckhorn, and part of the reason why you're not drilling here right away is Lanefoot, because of the elevation and the topography, it's it's pretty much a year-round drill area. Buckhorn is not. Buckhorn's a mountain, so things will get sketchy there in a few weeks, and you want to get as many holes done as you can. I mean, is there anything you can say about Buckhorn? I mean, that was. I mean, I don't know if you mentioned earlier that there's going to be two drill rigs there now. So I mean, obviously you want to get some stuff done before the snow flies. Can you give us any sense of what's going on over there?
Yeah, well, so we've got our permits in place for targets on BLM and on forest.
Right.
I expect to see the US forest permits completed imminently. I've been saying that for a while. Tomorrow or Monday or Tuesday, or not Monday because Monday's a holiday, but tomorrow or Tuesday or Wednesday, somewhere in that time, and that gives us some really high priority targets. We've got some difficult holes here actually, where we're losing water and we're just struggling along. We have a second rig and we need to get more done here. Our Lanefoot project is here, and it's much lower elevation. It's about 3,200 feet, whereas this gets up to about 55. So you are going to get a winter sooner and a harsher winter. And it doesn't mean you can't mine there, but it certainly means drilling is going to be less exciting. And it's not the drilling that's difficult, but we'll bring our water in by water truck. And if the roads are really difficult, it's tough to get a big water truck into a slippery road. That's probably the most limiting factor for us. So right now it's go time. My dream is to have a discovery here, which is what we're seeing now at Lanefoot, but also have something happening here. And I think that's the reality for this year. We've got two rigs. We've got, even if we can just get the last 4 targets drilled here, the targets are really advanced. These are not geological targets. These are geological, magnetics, conductors. We got geochemistry, both in soil and rock, and they're really well-developed targets. We're using a data set that's probably worth $12 to $15 million with what we've done and with what we got from Kinross. These are not lightweight targets. These are some really nice looking targets, and they're close to a 1.3 million ounce gold deposit with an average grade of 13 grams per ton. So this is the type of place you want to be looking for a deposit. So we'll get as much done as we can. Now we've got a fairly decent window. We've got more than a month, but you just never know what the season's going to give you. So we want to pour it on, get as much done as we can. We just got those results this week for Lanefoot. We're now scrambling to get more of those targets permitted. So what we do here will give us more time for getting some permits here, and that's on state land. And I think we've got some targets already to go, but we'll want more, because once we start drilling here, we really would like to keep it moving along. And here, being at 3,200 feet elevation, you can drill all year round quite easily. I envision us drilling up until the end of December and shutting down for Christmas break. So a fair bit of drilling here and Buckhorn as well. And hopefully our problematic drilling in one of our key targets has just been a killer for us, trying to get through. And I think we're through that now, and we'll see more targets drilled.
Okay. So I mean, there you have it. I mean, new discovery, and I think it's fair to call it a new discovery now, knowing what we know now about the original Lanefoot mine. Tons of target, high grade potential, shallow, It looks like I don't think you guys have had any trouble drilling there, unlike Buckhorn. So it's something once you get back there, you can put a lot of drill holes into it and have tons of news flow. Buckhorn
Yeah.
2.0, trickier drilling, but I mean, I think your guys have probably moved to an easier target, and a bigger drill rig is in there as of today to test some of the more difficult stuff. But you probably got a month, maybe more. I mean, it's only the start of October, so you might even have a month and a half if you get lucky this year. So you should get several targets done there. Those are all high priority targets, multiple data sets. Between these two project areas, I mean, I think there's room for some good news here and an extended period of it. I mean, I really do like this input thing. This feels like something that can generate a lot of good drill holes for months and months and months. So it feels like you really kind of turned the corner here, Mark. I know how hard you guys have been working to get to this point, but it feels to me like you're going to have some fun with this stuff again.
Yeah, one thing about Lanefoot is I love the fact that you go in and test a target that you hit last year and you're following up and you get consistent results. And we haven't seen a lot of that, oversight. We get a decent result, we'd go back out and test it. We got something completely different. And this is really very exciting. And it's so nice to be at low elevation and within 11 kilometers of an existing mill that's on care and maintenance. I mean, these are all there are so many good points about this area and this project.
Yeah, no, it sounds good. I mean, ADZ on the venture, DDNNF, OTC. I think we're going to be seeing a lot more news now going forward, and it feels to me like we're going to be seeing better news, and Mark has got the equipment and the cash now to put a lot of drill holes into these two areas. So I think there should be lots of news coming, and I think a bunch of it's going to be good. Thanks for coming to walk us through this. I know it's a little different. I wanted to be sure subscribers could understand why this release was important, aside from the fact that it had a good drill intercept. To me, it felt like more of a game changer than some of your earlier high grade intercepts, because it feels like you've got a system and a targeting and vectoring method now that feels like it really works. So that really makes your life a lot easier going forward
And you
when it
really
comes
did.
to
That's a good point, because it's a good point that you make. We've spent a lot of years developing targets. We've done all the surveys, every survey you can think of out here. And those surveys are now done, and we've now got the data set, and we're now down to a point where we're testing them. It's really down to drilling. There's not much more we can do with Lanefoot other than drill. And
Right.
the only way we can figure out where these things are going is by drilling. And I think this is a great position to be in. The same goes for Buckhorn. We can't do anything more to develop targets. The targets are developed. They're high quality targets, but they're developed, and now you just have to drill them. And that's a great position to be in.
Okay, I'm glad to hear you get two rigs there. So there you have it, folks. Keep an eye on this one. I do think after a bit of a drought, we're going to be seeing some good news going forward. Thanks for coming by, Mark. I'm sure we will be talking again soon.